Welcome to STEM Kits from iBio Institute. Today, we will be measuring wind speed using a measuring tool called an anemometer. You will build a simple anemometer that you will calibrate so that the number of rotations will tell you the wind speed. My name is Grace, and along with the rest of our STEM Kit team, I will be guiding you through building and using an anemometer. Doing an investigation scientifically is different from just playing around. Scientists conduct their experimentation in a very deliberate way. When taking measurements of a changing environmental condition like wind, it is crucial to use methods that can be repeated consistently so that the data is dependable. In this investigation, you will construct an anemometer and calibrate it so that it will measure accurately. Like all scientists, you will make careful observations to make accurate measurements. Scientists always record their data accurately so that they can communicate their findings to other scientists. You have data charts in your STEM Kit instructions that you can use as a record for your work. Measure carefully and don't forget to write your data down. There is nothing more wonderful than the movement of a breeze on a hot summer day. The slight air movement of a breeze has the power to cool us off. When the force of air movement becomes stronger, the wind that results has the ability to create electricity, move ships, and create different types of weather. Wind is one of the major influences on weather and climate. As it moves, it picks up heat and moisture, as well as pollutants to different areas of the earth. But what makes wind? Believe it or not, it's the sun. Solar energy from the sun heats the surface of the earth more at the equator than it does on other areas of the earth. The warm air rises, creating a space of low air pressure, and cooler air rushes in to take its place. This is what creates the air movement that we call wind. The bigger the low pressure space becomes, the faster and more forceful the winds will be as the cooler air moves in. The direction of the wind is influenced by the rotation of the earth. As the earth spins, it twists the air currents, deflecting them to the right or left, depending on whether you live in the northern or southern hemisphere. This is called the Coriolis effect, and it determines the direction of the prevailing winds. We can measure the speed of wind using an anemometer. It is a common weather station instrument, and the most common anemometer is called a rotational anemometer. This is the type of anemometer that we will be making. It is generally made of 4 cups on horizontal arms which are held above the ground on a pole. The air flows past the cups, which turns the arms at a rate roughly proportional to the wind speed. To measure wind speed, we start by counting the number of turns the cups make over a specific time. This number can be used to determine the wind speed. You will use your anemometer to measure the wind speed where you live. Let's get started. Now that we've learned a little bit about how an anemometer works, it's time to make our own. To build our anemometer, we will need 4 3-ounce plastic cups, 1 push pin, 2 non-flexible plastic straws, 1 pencil with an eraser, tape, 1 Play-Doh container, and a sticker. The first step to building our anemometer is to connect our straws. Make a cross with the straws on the table in front of you. Then, tape your straws together in the middle so that your cross has 4 legs of equal length. Make sure they are taped securely enough that the straws don't move around. Once we've made our cross of straws, it's time to add our plastic cups to catch the wind. Take one of your plastic cups and align it sideways on one of the straw extensions as you see us doing in the video on the screen. Shift the cup so that it tilts slightly upward and tape it securely to the straw. Now take your sticker and attach it to the side of this cup. This is now your lead cup, and the sticker will help you differentiate it from the other cups while the anemometer is spinning. After your first cup is secured, attach your 3 remaining cups to the 3 remaining straw extensions. They should be facing the same direction as your first cup and tilted slightly upward. Ensure that all the cups are taped in approximately the same place. Now that your cups are attached, it's time to make the axle. Push your pin through the center of the straws where you taped them together. Use the pin to slightly widen the hole you just made by moving it back and forth in a circular pattern. Once the hole is wide enough, insert the pin into the eraser of your pencil like you see us doing in the video. This will create your axle. Spin the straws several times in both directions to help the anemometer spin more freely. If it's still struggling to spin, no worries. Use your pin to make the hole bigger again. Then try spinning the straws a few more times until it moves freely. Finally, we need to make our Play-Doh base. Open your Play-Doh container and insert the pencil into the center of the Play-Doh. The base of your pencil should touch the base of the container. This will keep your anemometer upright in the wind. If you prefer, you can also hold your anemometer in your hand while measuring wind speed. It's up to you. Nice work so far. You've built your anemometer and now it's time to test it out. Before we can measure wind speed, we need to calibrate our anemometer. To calibrate, you should hold your anemometer in your hand, so take it out of the Play-Doh. On a windless day, have an adult drive you down the street at 10 miles per hour. The number of times your anemometer spins in 30 seconds will be consistent with the force of wind blowing at 10 miles per hour. Hold the anemometer out the window and count the number of rotations in 30 seconds. Record this number in data table 1. For example, my anemometer spun 20 times, so I'm going to write a 20 there. Repeat this 3 more times so that you have 4 trials, and record each result in data table 1. Add all of these numbers together to find your total, and then divide your total by 4 to find your average. To find the number of turns for 1 mile per hour, divide your average by 10 and write your result in the bottom row of data table 1. My result is 2.5 turns for 1 mile per hour. What's yours? Pause the video now to follow our procedure for calibrating your anemometer. Now we're finally ready to measure wind speed. Place your anemometer in a source of wind and count the number of revolutions it makes in 30 seconds. Record your results in data table 2. Repeat this 3 more times until you have completed and recorded all 4 trials in data table 2. Now add these 4 numbers together and record the total in the table. Divide your total by 4 to find your average and record that in the table as well. Finally, take the average number of turns from data table 2 and divide that number by the number of turns for 1 mile per hour that you recorded in data table 1. If you remember, I recorded 2.5 turns for 1 mile per hour, so I would divide my average by 2.5. Once you've done this calculation, record your answer in the bottom row of data table 2. You've measured wind speed. You all have done such a great job today. You've built your own anemometer and measured the wind speed. Amazing! Feel free to pause the video now to follow our procedure to measure wind speed. STEMKits is a product of iBio, delivering industry-led STEM programs for teachers and students to inspire a new generation of innovators and entrepreneurs. To learn more about iBio and its programs, visit www.ibio.org.